For decades, technologists have chased a specific dream, leaving our fragile physical bodies behind and moving our minds entirely into computers. By translating the brain into code, a person could theoretically achieve functional immortality. They could survive indefinitely without disease, travel through deep space free from cosmic radiation, or even precisely edit their own personality traits like lines of software. This idea is known as mind uploading. Prominent computer scientists and futurists, like Ray Kurzweil, argue that transitioning to a synthetic hardware form is the logical next step in human evolution. But a human mind operates very differently than a computer file. You cannot simply drag and drop consciousness onto a hard drive. The process of migrating an organic brain into a digital realm involves physical and philosophical risks that we are only beginning to quantify. To make this a reality, scientists have to surmount a specific sequence of challenges, starting with the sheer physical limits of engineering. If even a single stage in this transition fails, the result could be a permanent erasure of the person trying it. The effort begins with the data, specifically the capacity to map and compute every physical structure inside the human skull. The difficulty is a matter of scale. An adult brain houses around 86 billion neurons. Together, they form an estimated 1 quadrillion microscopic neural connections. One proposed method for capturing this architecture is serial sectioning. The organic brain is frozen solid and then shaved away layer by layer with an automated microscopic blade. Scanners record the exposed surfaces, eventually creating a highly detailed 3D map of the entire neural network. But this incredibly complex map, known as a connectome, is just a static blueprint. It shows where the wires go, but it doesn't do anything on its own. To animate that wiring diagram, a supercomputer would need to accurately simulate the electrodynamics and chemical binding laws of every single synapse, updating the entire system from 1 microsecond to the next. Computer processing power continues to grow exponentially, meaning the hardware to run a simulation like this might exist within a few decades. Yet a perfect hardware simulation means nothing if the resulting software fails to wake up. If the map is the hardware, the next question is whether the software actually possesses a sense of self. A core concept in cognitive science is physicalism. This is the idea that the mind is a product of the brain's physical structure and chemistry. If this holds true, then replicating that exact structure in software should naturally generate a conscious mind. But there is a disturbing alternative. The computer could process sensory inputs and generate human responses, talking and reacting as you would, while experiencing no internal life. In philosophy, this is the philosophical zombie, an empty automaton mimicking human behavior. Thinkers like philosopher David Chalmers have spent years exploring this specific dilemma. Chalmers proposes a concept called organizational invariance. This suggests that consciousness is tied to the patterns of causal organization in a system. If a digital simulation behaves exactly like its biological counterpart, the material housing it, whether it's organic tissue or silicon, does not matter. Even if the simulation does wake up and feel things, we are left with a paradox that can't be solved from the outside. Whose life is it actually feeling? Even if a digital mind wakes up and feels like a person, there is no guarantee that person is you. We can see the problem by imagining a non-destructive scan. If technology advances enough to map your brain while leaving your body intact, the process results in 2 functioning minds, a biological you and a digital you. Because subjective consciousness cannot occupy 2 separate bodies at the same time, the digital upload has to be a distinct entity, which means if you use a destructive method that shreds your biological brain to create the scan, you aren't migrating your mind. You are simply destroying yourself to launch a replica. There is one theoretical workaround to this identity crisis, known as gradual uploading. Instead of scanning everything at once, imagine microscopic nanobots entering your brain. Over years, they learn the function of individual cells and replace your biological neurons with synthetic counterparts, one by one. By the time the process finishes, your biological brain is gone, but the continuous stream of consciousness was never broken. Even with this method, consciousness remains entirely subjective. An outside observer can never confirm if the original person is still in there. The first person to attempt an upload must face the possibility of absolute non-existence to find out. If we assume these transitions are successful, we arrive at a society populated by emulated minds, or Ms. An individual M could create a backup file of their own mind, guaranteeing their safety from accidents. They could embark on interstellar travel by pausing their consciousness for 1,000 years, or transfer themselves to faster hardware to operate at superhuman cognitive speeds. But they would also face new existential threats. In a fully digital population, a biological pandemic is no longer a concern, but a sophisticated computer virus could instantly delete millions of citizens. We are a long way from the age of Ms, but the effort to achieve mind uploading forces us to confront grounded, immediate questions. We have to map out exactly what constitutes a mind and define what makes us who we are. Moving from flesh to silicon is more than a technical upgrade. It's a decision with no possibility of return. While we may never know what it feels like to be code, the attempt to build an artificial mind forces us to finally confront how we've been operating in the first place.